All right. So just, man, Dean, you're so kind and uplifting. And P.S., I know you two did not have the same car originally.
Dean does not have.
You had a King.
I had a King.
Yeah, dude. King's back here, Dean.
Is it crazy?
I didn't even notice that.
Okay. So I just want to read off a couple of things that I'm just noticing, just because I think it'd be good for y'all to hear what some of your peers are saying. If you're still working on your reflection, cool. But after that, we're going to get started with the day. But one of the things I really like, it says, describe the ways you've helped yourself learn the content. Someone just said, I just trusted Mr. Kinney's way of learning, right? I talked about that with one of the previous students. Like, when he trusted me, he ended up being even more successful than he ever did, right? Let's see. I'm getting a lot of, I don't care when you learn, I care what that you learn, right? I've got the making mistakes, getting messy idea. Love that. This person, so like if you're not doing this, one of the things that someone said that's helped them a lot is asking questions, right? I need you to remember, like if you have something you're confused on, that you're stuck on, ask those questions. You can ask those questions in small group time, but even during the whole class discussion time, that's really big. Writing on the board, so remember when you write on the board, I can see what you are thinking, and I can give you feedback, and I can ask you questions, give you hints, and things like that. So like writing on the board is not random, it's intentionally designed so that I can give you quicker feedback than say if you're just writing on a sheet of paper. I love this one, going over my mistakes, right? I talk with my son all the time that I ask him, hey buddy, you made a mistake. Is that okay? And we're working on him understanding, yes, like mistakes are how we learn and grow. Mistakes, as he likes to say, make you bigger and stronger, right? So yeah, learn from those mistakes. One person here, and I'm very glad to see that at least one person is doing this, but doing the practice questions, guys. Cannot emphasize it enough. Like it may seem easy or you may learn it during class time to a certain degree, but if you don't take the time to do the check your understanding, do the practice questions, it's not going to cement itself. You've got to do those practice questions. Yep, it's okay to make mistakes, right? Mistakes make you grow in your learning, right? If you're struggling, ask for help. Trying to see some others. Just getting a lot of the same things. I'm not just skipping over people. Paying attention and studying, right? Asking, things like that. All right, gets me back to the beginning. So hopefully, maybe if you're struggling a little bit, you get a little insight of what to do, or even if you're doing well, you can say, man, that's actually a good thing. I might want to attend to that. So you all have amazing ideas. I want you to learn and grow from each other. And that's the point. You learn and grow, you're going to be all right. So for today, we are going to finish up. Okay, so we started that function sort a little bit, but we're going to do a new task today and then go back to that function sort, because there's like one thing that seems pretty consistent that we remembered about a function, but we don't remember actually what a function is. And so it's going to be really, really important. So I will point this out. If you did your reflection on your proficiency scales, at this point, like hopefully everyone knows the 5 mathematical representations. We talk about it. We use them every single day. But you need to be clear with that language. One of the biggest things that hurt me on that DYU the other day was when I asked what mathematical representation it was, y'all told me geometric sequence. Guys, that's a sequence, not a representation. We need to think about our 5 mathematical representations that we have. All right. Relations and functions, that's what we're going to talk heavily about today. Now, granted, we already know what a relation is. What is a relation? That's equivalent relations. Equivalence is really important. But that's not what a relation is. A relation is part of that. But it's not the same inputs and outputs. It's just inputs doing what? Doesn't have to have the same outputs. That's the idea of equivalence. Say again.
Changing output.
Not necessarily just changing outputs. A relation is any time an input is mapped to an output. So like if you have a pair of inputs and outputs, what do you have? A relation, right? Like, if there's any kind of relationship between inputs and outputs, you've got a relation. The question is, when do those relations become functions? And more importantly, for your sake, why do I care? So we're going to get into that idea of why do we care about functions today. And so that's going to help us build into identifying domain and range of relations and focusing on functions. And there's the idea of equivalence, right? Remember, the idea of equivalence is the same inputs mapped to the same outputs, okay? And notice you do have to be able to explain why they are equivalent. You got to show that. And so hopefully we can go from tables to graphs, graphs to tables, etc. We'll be focusing on x-intercepts and y-intercepts later. This is the arithmetic sequence and geometric sequences one. We need to be able to do all of these things. We got to know about function notation. So if you do not have the entire foundation marked off on arithmetic and geometric sequences, that's where you know that you need to study. Study your notes and the concepts first and foremost, but then yeah, do the practice problems. You need both of those things. I need to get y'all some more practice problems now that I'm thinking about it, but you have the solutions for the practice problems you've already been given. I might I'll have to run them off for Monday. Okay. We need to be able to identify arithmetic and geometric sequences. No matter what representation you have, what's kind of the key to an arithmetic sequence?
Addition.
Not just addition,
Constant.
not multiplication,
Constant.
constant. What do you do with factors?
You multiply.
You multiply by factors. No, so it's not that. So, Finney, here's why I say it's not just addition. So right here, I'm adding, right?
Yep.
But is that arithmetic?
No.
Why is that not arithmetic?
The changes.
It's changing how much I add by, right? So it's not just that we're adding, it's that we are, how are we adding? To make it arithmetic. Say it louder. We're constantly, repeatedly adding, right? So it's that constant additive rate of change. We got to remember that, okay? Now, that constant additive rate of change, does anyone remember the name for it? There's actually two names for a constant additive rate of change. It's not a constant factor, because that's what we multiply by, right? Might be in that proficiency scale somewhere, one of them. I asked, what is the name of that constant additive rate of change? Well, there's two. So we show it as multiplication, but look at that proficiency scale. Constant difference. So remember, the idea of a constant difference is what we are constantly adding by. Remember, we find a difference by subtracting, and subtracting and adding are just two sides of the same coin. So focus on that language. Constant, meaning it stays the same. Difference, right? It is a difference, or it's adding, it's how much we're adding by. Okay, notice it's also right here. Does anyone remember what the other name of that constant additive rate of change is? Because we see it as a line. What's that rate of change for a line called? It is linear, but what's it called? The slope. Remember that the rate of change for a line is called the slope. So that constant additive rate of change, you can call it the slope or you can call it a constant difference. I'm good with either one, okay? All right. Geometric, finally. What makes a sequence geometric? Not just repeated multiplication. What kind of constant multiplication? Constant multiplicative rate of change called a what, Walter? Yeah. No. Yeah, but what is the name of that? I'm calling on you for a reason. You said it earlier.
Constant factor.
Oh yeah, that's right, a constant factor, because what do we do with factors? We multiply, right? Constant means it stays the same, but factors, we multiply. So guys, I'm going over this not for my sake, I know these things, I'm going over this because every now and then, and by every now and then, every time, every day, we need to remind ourselves of these key fundamental things. We're going to be applying these and going deeper with these ideas each day. So you need to understand this. And there's a whole body of research that I'm looking into and trying to go deeper with on my own that talks about how important the language side of this is. If you understand the language, one, it's gonna help you communicate better, right? Like some of y'all have said on the reflections of, hey, I can ask questions in my small groups. Well, if you don't even have the language, how are you gonna accurately or precisely ask that question? And if you were trying to help someone in your group, if you don't have the language, then you're not gonna be able to clearly communicate how to tackle the problem. You gotta understand the language behind it. And then we develop our understanding and our appreciation of the language as we communicate and as we talk. So keep that in mind. And then we do have recursive and explicit equations, so we've got to work on that a little bit. So notice here, foundation, we're talking about the slope, and we're talking about a constant factor. Actually, that's not right now. But all of these foundational pieces come from that arithmetic and geometric sequences. This is what we're going to be working on over the next couple of days. And this is the last bit of this unit. My guess is we're going to have a DYU early next week, and we're probably going to test by next Friday, okay, on arithmetic and geometric sequences. Because when we get into linear and exponential functions, it doesn't change much, okay? We've already talked about it. What makes a sequence? The fact that it's discrete, right? Like we have those gaps and those points. But wasn't an arithmetic sequence just a, what type of function? Starts with an L? It was a linear function, wasn't it? A geometric sequence had what type of curve? Exponential curve, right? So what we're going to be going into doesn't change much. Mostly what y'all need is practice with the equation. So when we go into the continuous side of things, then that's going to be some more of your practice. We get a chance to grow and learn. Alright, so we started this yesterday, and when I was talking with small groups, it didn't seem like we really knew 100% how to determine if these relations were functions or not. This one right here at least. Did anyone come up with a rule or a way that we might sort these out, Finney?
I know you can do a table to find out.
A table could definitely help here. I will point that out. Can you ever make another mathematical representation? Yes. I do, a graph maybe. Oh yeah, by the way, a lot of y'all seemed really comfortable with these graphs here determining if it was a function or not, right?
Yes.
Okay, so if you were to take these points right here and make a graph out of it, could that help you maybe? Yeah, 100%, right? So that's a great strategy. See, one thing I want us to develop in this class is not just memorizing the equations or the rules, but understanding how to flexibly change among mathematical representations. Man, Mr. Kinney, I don't particularly love word problems. Okay, make a table or a graph. Let that drive your equation. I don't particularly love graphs. Okay, make a table. That can help as well. Okay, so you can do that. That's a great strategy, Rihanna. But I will say, I want us to also be able to look at this set of points and know if it's a function or not. Okay? So that's what we're going to be working on today. Notice here's a table, right? That's very similar to the sets of points we just saw. And from at least from what I could tell yesterday, we weren't sure if these were functions or not. I think, Dean, you were talking about whether there was a pattern or not, right? And so I will say this. When I look here, I'm trying to find one. There's a pattern here, right? It's not constantly adding or constantly multiplying, but there's a pattern here. Still not a function though. We need to learn why, okay? So, when we say patterns, most functions that we study will have patterns, but not all of them, right? Some of them are kind of random. But then here, so which of these two, looking at the graphs, which of these were functions? Okay, so the first one and the fourth one, the line and the, does anyone remember that bottom right one? Say it again. That's a parabola. Yeah. Does anyone remember what type of function that parabola is? Starts with a Q.
Quadratic.
Yeah, there we go, right? Parabolas are quadratic functions, okay? And so, at least what I remember seeing, a lot of us were drawing vertical lines here. And I heard talk about, hey, because that vertical line touches more than one point, it's not a function. And please hear me clearly on this. That's known as the vertical line test. But that doesn't help you with a table. Doesn't help you with an equation. So we need a little bit better understanding. Because if you actually go to the definition of what a function is, it makes your job a whole lot easier on identifying functions, whether it's a graph or something else. Now, I can tell that I'm putting a handful of us to sleep, so we need to actually get going with this lesson as soon as I find where I put the sheets. There they are. I think. I hope. Yep. Okay, so this mathematic activity is designed so that you can actually work through the first 5 questions, or the 5 questions, in your small groups. And so I'm going to have you get going on this task. And then I'm going to support you by asking questions in your small group. And then we're going to build an understanding or definition of a function after this. Now, here's the context. What in the World Cup? So the World Cup is for what sport? Soccer, right? So the FIFA World Cup is an international soccer tournament played every 4 years. The table below gives data about the year in which the tournament was held, the country who hosted the tournament, the winner of the tournament, and the total number of goals scored. All right? So we've got our years, we've got our host country, we got our winner, and we got the number of goals scored. What I need you to do is answer these 5 questions, and then we're going to bring it all together and figure out, okay, what is a function then? We ready? Ready to start answering some questions? Getting up at vertical surfaces and go!
So, vertical surfaces.
That's right. All right. Hey guys, I asked you to walk towards the chalkboard.
Walk towards the chalkboard.
Come on, let's talk about it. Okay? So, what I want to emphasize is a lot of us are talking about a lot of really good things. So I want us to notice. So I'm going to go through number 1 and 2 to help us build up to 3 through 5. So remember, the whole reason why I had you work through this is so that you could see maybe a pattern. I don't know that I've actually said this because we spend a lot of time in statistics. But when we talk about mathematics, what I really want you to focus on is math is the study of patterns and relationships. And so I talked about earlier, hey, this language is really important because once we found in mathematics a pattern or a relationship, we named it. Like that's where math really comes from, is we are naming these patterns and relationships. And so we need to find a pattern or relationship here. So the question is, hey, who won the World Cup in 2006? So if I look at the year 2006, what do you know?
Italy won.
Italy won it, right? If I tell you the year is 2002, who won it?
Brazil.
Brazil won it, right? You can instantly know, hey, by the way, what am I going to call the 2002 and the Brazil in the context of this relationship? Oh yeah, based on this input, I immediately know this output, right? Okay, cool. How many goals were scored in the tournament? So 2006, there were how many goals in that tournament? 161. So I was immediately able to know that output, right?
Yeah.
But I think the next one is, no, oh yeah, hold on. Yeah, the next one is actually where some of us missed the point. We actually missed a really, really important part of number 2. When I look at number 2, it says when Argentina won the tournament, how many goals were scored? And I see a couple of answers. I see over there 102. Guys, look at your sheet. When Argentina won, were there 102 goals scored? Wait, there were multiple years that Argentina won?
Yeah.
Okay, so Argentina could have had 132 goals, right? Or what else? What are
102.
or 102?
But you
Were there any other options?
234. That's it.
I say, so someone said 234 because I think you added those together, but it just says when Argentina won the World Cup, how many goals were scored, say that year, okay? So the reality is, and I can't remember who said it, I think it was Victoria. Victoria, what did you say when I gave that example earlier? And I was asking about,
Veronica.
Answer wrong.
Jaden. It ain't funny. She has a name. Respectfully use her name so that you can respectfully communicate with her. Thank you. All right, so when I was asking you earlier, I can't remember the example I gave. Maybe it was it Germany, and I asked you what year they hosted? Okay, so like earlier, I was talking to that group to help them think about number 5, and I said, hey, if I tell you that Germany hosted, what year is it?
We don't know.
Victoria. What did you say? We don't know because Germany hosted in 1974 and 2006. Fun fact, that was the first year I ever watched the World Cup. Yep, first year.
We wasn't even born.
I know. Yeah, I know. Okay, so, and I was in high school. So, I think it was actually no, that was my freshman year of high school. I was going to say junior year, but it's freshman. All right, 2006, or 1974 and 2006. So the reality is sometimes I can take an input and instantly know the output, because how many outputs were there? One. But sometimes when I have an input, do I instantly know the output? No. So which of those is more useful? Hey, listen to me again on this. Which one's more useful? When I know an input and instantly know the output, or when I don't know the output? When you instantly know the output.
It's like statistical, right? No, that's
Not quite. So break away from statistical. We're just talking about functions or not functions. Okay. Right here. Knowing an input instantly tells us the output. Any guesses what we're going to call that? Not equivalent. Guys, what's it called when knowing the input immediately tells us the output? What did you say? Not a relation.
Relation.
No, bro. I don't know.
Hey guys, y'all are already forgetting what this whole lesson was about. What we kicked it off talking about, huh? Say it again. Say it over here. Oh, that's right. What are we trying to find out? Functions. Remember, we already addressed a relation. A relation just means there's an input and an output. All of these are relations, okay? But which one's a function? Number one. Why? The year instantly tells us, what was number three? The year instantly tells us who won. So notice, one input mapped to how many outputs?
One.
Mapped to one and only one output. That tells us a lot of information. But look here at number 4. Okay? Does knowing who won the tournament determine the number of goals scored in the tournament? No, because we don't know the year, right? So in this case, one input can map to how many outputs? Is it still only one output? Guys, what does number 4 says, who won the tournament, determine the number of goals? So, again, I think I'd use Germany as an instance with a couple. If I tell you Germany won, how many goals did they score? Or how many goals were scored that tournament? We don't know, because it could be 140. It could be 97. It could be 115. Or it could be 171. So in that case, one input was mapping to multiple outputs, right? In this case, 4 outputs, but the most important is that it was multiple. It was more than one. One input can map to multiple outputs. Last one, number 5 as well. Does knowing the host country determine the year in which the tournament was played? Well, we already looked at it. If I tell you, hey, Germany hosted, do we know which year it was? No. Because the host can host multiple times. So in this case, one input maps to multiple outputs. Now, one thing I'm going to point out here is you should definitely have in yellow like these answers, but I would also probably note the purple like examples here as well, and the extra clarification I'm putting down, because we're going to do some quick notes in a minute. But the one thing I want to pause and I do want to point out is this. It's like this goes with number 5, right? Germany hosted, and they could have it could have been 2 different years. Now, if I told you that the U.S. hosted, do you know what year it is?
Yeah.
What year is it?
1994.
1994, right? Okay. If I tell you that Sweden hosted, do we know what year it is?
Yeah.
What year is it? 1958. So, notice right here, okay, there's lots of one inputs mapping to one and only one output. But if there is at least one input mapping to multiple outputs, it is not going to be a function. So it doesn't have to be every input. It doesn't even have to be multiple inputs. It just has to be at least one input is mapping to multiple outputs. If that happens, it is not a function. Is it still a relation? Yes. Right? So we're going to do some wrap-up notes to this soon, but this is kind of important. Not kind of, this is important. So this is the only function. These are all relations, but this is the only function. At least from numbers 3 through 5. I think there are other functions. Yeah, there's other functions here, but this is the only one that we have. Numbers 4 and 5, those no's, they are not a function. All right. So numbers 1 and 2 are starting to get us to 3 through 5. Okay, please update your notes based on this information. I will point this out. I like what Victoria's doing. Victoria has her notes, the answers that her group did. But then in purple, she is adding the notes that I added up here, right? So adding the note. I do want to reemphasize, I see a handful of us taking that suggestion that I recommended from what Victoria did. I think it's really good to add what the notes I made separately up there in a different color so that that really pops out. You can see the examples, you can see that extra information. We're going to leave that up there if you need to continue to write that stuff in a minute, but I do want to go ahead and start these quick notes. So I may pause if I were you, make sure you get these quick notes down, because this is a wrap-up of all the big ideas out of this lesson.
What is LT?
Learning target. Right, so like what is the priorities that we need to be learning out of this? These are the learning targets. So a relation. I'm going to introduce a new word to explain something that we've already been using. And by introduce, I mean look at a word that I know you used last year in Algebra 1. But a relation, what is that?
We have the same input and output. No, we just talked about that. Okay, let me see.
Things that go together, yes, but like what are the things that need to go together?
The same input and output.
It doesn't have to be the same input and output. And there's a word that I keep using over there that we wrote notes about that we should be thinking
It has
about.
to have the same function.
We're going to talk about functions in a second. I'm just talking about relations.
Same output.
Remember, same. Okay, pause for a second, guys. When we say input mapping to the same output, that's the idea of something that starts with an E. Equivalent, right? The same inputs mapping to the same outputs is when we have equivalent relations, where the table, the graph, the equations all tell the same story, the same inputs mapping to the same outputs. But what is a relation?
One input mapped to one output.
Close.
Or
That's
one
later.
output different.
It just has to be, let's say it this way, any mapping of inputs
Oh,
to
God.
what? Any mapping of inputs to, guys, we gotta have inputs and we gotta have outputs, so it's any mapping of inputs to outputs, there we go. When we talk about a relation, we have inputs mapping to outputs. No special rules. A relation just has inputs being mapped to outputs. That's it. When you hear me use the word relation, it could be a graph, it could be a table, it could be an equation, it could be anything that has what two things? Inputs and outputs. Okay? That's what a relation is. That's it. Now, one thing I do want to remind you, because this is what we're going to go into soon, does anyone remember what we call the collection of all inputs? Mm-hmm.
That's our starting point.
Mm-hmm. Starting point usually is an output anyways.
Different.
Domain. That thing, that domain that you talked about last year, that thing that had interval notation when you like negative infinity to infinity, what we're talking about with that is what are all the inputs? The domain is the set of all inputs. So the set of all inputs is known as the domain. The collection of all inputs is known as the domain. So when someone says domain, yes, there's a notation for it, yes, there's a way to write it, but if you hear the word domain, you need to think, oh, those are my inputs. Domain, that's all my inputs. That's all my inputs. Okay? So what are we going to call the collection of all outputs?
Range.
The range, right? Let's be nice and respectful. I know sometimes it's a challenge for us, but you know, it's helpful. Even when people are frustrated, like Finn. I love him.
You're not cute.
I mean, Coriana, I love you too, but you ain't always a peach. Come on now.
Baby, you ain't no peach.
Oh my.
Listen, I can say that, don't you do it.
Like, shut up.
Coriana, I just said, just chill.
Like he literally.
Oh, that would, it really mean shut up.
Yes.
Okay, go ahead, look at me.
I mean, it's not the most respectful way to say it either. Okay? So, a relation is any mapping of inputs to outputs, so my domain to my range. Now, in order for a relation to be a function, what has to be true?
It has to be equivalent.
No.
It has to have.
Equivalence is multiple representations of functions. I'm talking about for a relation to be a function is what we just talked about over there. Which one of those was a function?
Oh, it has to have. No, it tells us the input.
One input can only map to one output. So, and this has to be, and this needs to be clear, right? If there is any input, right here, Germany. Germany mapped to how many years of hosting?
2.
2. It was the only country that mapped to more than 1 year. But if there's any input that maps to multiple outputs, it's not a function, okay? So, in order for a relation to be a function, every input can map to one and what? And only one output. Okay? Every input can map to one and only one output. That's what makes something a function. Hold on to your question. I'm going to show you all graphically what it looks like in just a second. Okay? Okay, so I want us to go back and look at the graphs y'all were looking at earlier. Okay, right here. Okay, I'm gonna have to, can I erase the any mapping right here?
Yeah, you can erase it, sir.
Okay. Anybody need me to hold off? So I know Ivan's good. Anybody need me to hold off though? Okay, so right here, if I draw a vertical line, remember how y'all were drawing vertical lines yesterday?
Oh, I remember doing
So if I draw a vertical line right here, if I tell you x equals 1, how many outputs does x equal 1 have?
2.
Not even 2.
3.
Or not just 2, 3, right? So if I tell you that one input, do you know immediately what the output is?
Yes. No.
No, there's 3 options. I need you to recognize, right? Functions are useful because one input only maps to one output, so I know instantly what the output is. This one input mapped to 1, 2, 3 outputs. So if I tell you x equals 1, do you know what the output is?
No.
No. That's why the vertical line test works. The vertical line test is just a visual way with graphs to know if something's a function or not. But this definition right here This works whether it's a graph, a table, a word problem, on anything, right? As long as every input maps to one and only one output, what do you have? A function, okay? So I am going to make this note over here, okay? Just so we have an example. So like right here, would this be a function? No. Okay? Using the vertical line test. So vertical line test is fine, but we need to know what it's actually telling, right? This vertical line test, so vertical, by the way guys, this is going to be dumb. I don't know why this bothers me because I'm used to bad spelling all the time. Vertical is not spelled V-E-R-T-I-C-L-E. That is not vertical. This is how you spell vertical. I don't know why, but that's one of the ones that drives me bonkers. I'm not going to count it off or anything like that, but please spell vertical, right? Okay, this vertical line test shows one input is mapping to how many outputs? Look again. Multiple. Specifically here it has two outputs, right? That's the whole thing is the input is the X, the output is the Y. So how many Y's do I have? Two. So that one input is mapping to two outputs. So is this a function?
No.
I thought it was a function because it touches.
Remember, every input maps to one and only one output. So this has two outputs, right?
No.
So is that a function?
No.
So no. So this relation, notice it is still a relation, is not a function. Okay? So what you probably memorized last year was, hey, if that vertical line touches more than one point, it's not a function. Well, that's true, but why? Because it's showing that one input is mapping to multiple outputs. If one input maps to more than one output, if knowing the input doesn't tell you what the output is, it's not a function, but is it a relation?
Yes.
Yes. A relation just has mapping of inputs to outputs. Everything we're studying is relations. So that's how we determine functions. Okay?
Wait, because it has multiple outputs, it's not a function. I mean, multiple inputs.
Can we get Jessalyn Freeman for checkout?
She's on her way.
Thank you.
Must be nice.
Yeah, they're going to get ready back in 11th grade.
Something
That's
is-
for all.
I-
What is that for?
She did Caitlin. She
I
did.
just got to
This
class.
This?
No, no.
You might well, yeah. You get ready.
Oh yeah, that's like the year after COVID hit. Or 2 years after. It was maybe, I don't remember what year it was a long time ago.
That'd be nice, man.
Is it nice not being in class to learn?
No, I'm in this class.
Oh,
Only this class is
I don't know how you-
nice? Or you
I don't know how you
The
should feel
past
about
couple
that.
days, this class been going by fast. I don't know. No, not today. No.
I'm sorry you feel that way. Alright, see, so here's what we're about to do, okay? We're about to go back and to speed things up a little bit, and we're going to debate and discuss these things. What I'm going to do is I'm going to split these different relations up so that different groups work on different ones, okay? So let's do this. Each group's going to have a different set. Group 1, or ACEs, I should say it that way. ACEs, y'all are going to work on these relations. Identify which are functions and which ones are not functions, okay? What's wrong, Chelsea?
You're not even AC, so what's wrong?
Yeah.
John dead.
I know, right? Okay, so ACEs, you've got this set. We good with that?
Playing 2K all night.
Actually, let's do this. Looking around the room. Aces and kings. I want you to work on these these 4 relations and on these tables, okay? So aces and kings, you got these sets of points and you got these tables. Queens and jacks, because I want y'all to be able to compare these. Queens and jacks, you've got these mappings, that's literally what these are called, is mappings. And you've got these tables here. Is that all of them?
Yes.
Yeah.
Okay? So then let's repeat that, okay? So 9s and 8s, okay? 9s and 8s, you've got
Leia.
these points here
Wait.
and these tables here.
Wait,
What?
what's the thing?
9s and 8s, you've got these sets of points here,
Go back to ACES real quick.
and these tables here.
Why you gotta switch them up? Didn't they just?
Go back to ACES.
He ran out, so.
Oh my gosh, okay.
Y'all doing the same thing?
Yeah,
Like,
oh,
this is gonna be
You're
a
right,
long
we can
game.
speed things up. Pause and listen. Here's what we're gonna do. Aces and kings. Y'all only have these points.
Alright.
Each of these sets of points, you're looking at what's a function and what's not a function, okay?
Alright.
Queens and jacks, you've got these 4 tables. We good with that? Okay? Nines and eights, you have these mappings and these 2 tables right here.
I'm saying though, why we gotta get through that?
It's still 4 relations. Everyone else has had 4, Ivan. Thank you. Okay, 4s. Which set do y'all want to work on? You want to
They
do
ain't got
this
no
one
choice,
and that one?
listening.
Okay, so 4s, y'all have this mapping and this set of tables. All right, let's get up. Let's identify which of our relations are features.
I don't even have a sheet number.
You better find it.
You remember you made us cut it out, and but you never gave us a whole.
Please don't kill my
Area.
Sorry.
You're good. I want to emphasize something right here, okay? So, coming on over this way, excuse me, right here, okay? So looking at the queen's information, right here, okay, it helps when you're closer to the action, it helps you see things a little bit better. Now Walter, if you could scoot just a little bit so the camera can get it, that works too. So right here, one of the things that Walter came up and asked me then, and he said, wait, so Mr. Kinney, that means if the input for x is used twice, then it is not a function. So if your x is used twice, it is not a function. Man, that sounds pretty good, because if you have an input mapping to 2 outputs, it is not a function. One of the things I want to emphasize, I really like some of the language that some of y'all have been developing, and I want you to think about this in the future. Like, I keep asking the question, hey, if I look at -1 here, do you know what the output is?
Well, yes.
It's -2, like for sure, right? One of the other tables, let me look at that one. So we'll go 3, 3, 4, 4, 5, right? And then it's mapping to -1.
0, -1, 2, 0.
Okay? If I ask you, hey, what is the output for 5? What's the answer?
0.
0. But if I ask you, hey, what's the output for 3? You would say,
0.
No, you.
say it again, Malia.
Or -1.
We don't know. It's 0 or -1. So do we actually know what the output is?
No.
No.
So not a
So
function.
not a function, right? Okay, so this is good conversation. But I want to draw attention to one that was causing a little bit of confusion for 2 different groups. Right here is 1, 4, 6, 8, 1. Gut instinct, looking at this, is this going to be a function?
Yes.
Why not?
Because the one at the end.
Because-
It's the one at the end.
Then jumps back to left.
Exactly.
Okay? Hey guys, I need y'all to pay attention to this, so hold on. That 1 is happening twice, isn't it?
Yes.
Okay, but Chelsea, let me ask you a question. If I tell you the input is 1, what's the output?
We don't know. We got
But if I tell you the input is 1,
It's negative.
I changed it -2.
the output is -2. Are there any other outputs
Yes, it's the same.
for 1? I need y'all to notice. Hey, Parker.
I forgot what Ms. Moore said, like, you said it twice, I forgot. Wait,
But see, this is, hold on, see, like, we're remembering half-truths here. This is why I'm trying to focus. I need us to understand. If I tell you the input is 1,
I'ma
what
say
is the
-2.
output? -2. Are there any other outputs for 1?
No.
No. Hey guys, even though 1 showed up twice here, it mapped to the same output. So, is this a function? Yes. Hey guys, if knowing
I was right.
the input, knowing the input instantly tells you the output. Hey guys, I need you to focus on maybe trying to learn something. Knowing the input instantly tells you the output. What do we have? This is a function. Okay? So I need us to recognize and be careful, because Finney, what you said is usually how we think about functions. Hey, I see the input twice, so it's not a function, but that's not necessarily true. That one input, even though it's twice on the table, it maps to the same exact output. So knowing the input's 1, I know the output is negative 2.
Yeah, negative.
Input is 1, output's
I
negative 2.
couldn't see.
Okay? So we need to be careful with our definition. We need to be precise with what a function is.
Why is that? You said output is the starting point. Why?
So remember, it's when the input is 0, that's where you have your y-intercept, and so this output of 3, right, is your starting point. Because I would remind you, like when you have an exponential, what does this f of x stand for? Is that the input or the output?
I mean input. No, actually the output.
The whole f of x is the output. We got to recognize that. So notice, Finney, we're saying that a is an output. And the a is the starting output when my input is 0. Okay, so that's what I was saying there. All right, so let's quickly talk through a couple of these. So I want to look at what we were thinking on this one. Yeah, Dalton, can you scoot it up this way? Or turn it this way? Right here. All right, aces and kings. This first one right here, function or not a function?
Function.
Y'all said function?
I said
Function. I said it was a function
Okay, so Dalton, why are you thinking it's a function?
because the only repeat is the -2, but they have the same exact output, so they're practically repeated.
Okay, Dalton.
So then
So knowing
every-
the input of -2, we know the output is
1.
1. So is this a function?
Yes.
Yeah, knowing -3, the output
I
has
told
to be
y'all.
-2.
Thank you, bro.
The input -1 has to have an output of.
Oh, yeah. Yeah.
Hey,
What you call me?
so, hey, right here.
Focus, focus.
Hey, I just want you to both realize that the trash talk you're doing right now, mostly you, Jaden, is caught on camera right now. So you might want to stop.
What you mean? It's like a little competition work,
This
man.
camera can see me? Yeah.
No.
No, it doesn't have you on video right now.
Okay?
I got a question.
Go for it.
So when I graphed that, we were going like, we went from.
Do I like? I will point this out, guys. I want to point out -2, 1. So what Dean did with his group is he actually said he graphed it, right? So let's look at it. -1, 2, and -2, 1, same exact point, right? And then -3, -2. So like when I look here, and I look at a vertical line, does that vertical line ever hit more than 1 point?
No.
This is the same exact point, right? So we gotta pay attention to that, and that's what Dalton was saying, right? He said, hey, knowing that input of -2, I know the output is 1. But I do want to emphasize this. Hey, can you make a graph to visualize it and use your vertical line test? Yeah, think flexibly. Use multiple representations. This is why I started the whole unit with multiple representations discussion. Use what's comfy for you. For me, knowing the definition is the most helpful, because then I don't have to create a new representation every time. But there we go.
What are we going for? Like, start here, then connect the lines up here.
No. So this is a point right
Order
here.
from left to right.
-2 is mapping to 1. This is a point. 1 is mapping to -2. -1 is mapping to 2.
So it's
So this
not
is,
line.
when you have a point, this is input and output. So that point is telling us an input and output. So I'm glad you brought that up to make sure I could clarify it. Guys, please again, notice this is why we talk. When we have a misconception, I need to know that so that I can address it. Do you understand now? Okay. So second one down here, aces and kings, function or not a function?
Not a function.
Not a function? Aces, y'all agree? Yes?
Second
What's
one.
the issue with this one? Why is this second one not a function?
Because the one showing twice.
Yeah, not just because the one is showing twice. That one is mapping
One has
to
two different
two
outputs.
different outputs, right? Because remember, the -2 showed up twice, didn't it?
Yeah.
Okay? But it was still a function up here because it mapped to the same output. These are mapping to different outputs. All right, third one, function or not a function?
It's a function.
That's a
All the
function.
outputs are the same, but all the inputs are different.
Yeah. Be careful. A lot of people want to say this is not a function because, oh, Mr. Kenny, it's got a 0, it's got a 0, it's got a 0. But hey, if I tell you the input's -2, what's the output?
0.
0, you know that, right? If I tell you the input is 1, what's the output?
0.
You know that, right? So if the input immediately tells you the output, it is a
Zero. It's a
A
function.
function, thank you, goodness gracious.
Y'all said
Alright,
zero.
this one right here, function or not a function? Not a function. Which points are the problems in this one?
5 has 2 different
Yeah.
outputs.
Fives.
That 5 maps to 2 different outputs. Hey, by the way, I want y'all to hear me. Have you noticed the language I use every time is this one input is mapping to 2 different outputs? That's the language that we use within mathematics. Practice using that language as you're justifying your responses, as you're working on assessments, okay? Alright, these tables here.
Still function.
I fixed it.
No, it's a D.
It's a C and a
It's a
T.
C and a T.
They're together.
Water.
There we go. Is that better, Walter? That make you happier? Okay.
Water.
Hey, by the way, actually, let's pause. If I were you, I might at least write these down on that sheet to know which ones are functions and which ones are not functions and refer back to it.
Well, actually,
If you need the sheet.
You have an extra. You cut out.
But you can still have that third of a sheet and write it down. Guys, if I were you, I would at least note those. Whose sheet is still up here? The whole sheet is yours? This little one? Dude, quit. Again, I might make a note of which ones are functions, which ones are not functions.
Whole 5-minute discussion.
She said, what is different group? I just,
Y'all crazy.
like, once I hear the lab, it just.
Not the lab.
It's a domino effect. Like,
Birthday.
my fault.
Get your ish together.
Yeah, I just don't like it. Matter of fact, activate it. I'm not good. I'm not here. See?
Okay.
Yeah, he put it
So function, not a function, function, not a function.
Can we
What
put
time
graphs?
is it?
It is 11:22. So we'll get some time to learn.
They really-
Leveled that.
Hey, Benny, Oriana, just quit talking to each
Back in
other.
the statistics days, they were got some.
I love those days.
Dude,
Hey,
don't.
That's disrespectful.
okay? So, let's look at these here. We've already addressed them. This first one right here, function or not a function?
Function. That's function.
Yep. This one here,
Not a function.
not a function. And we're at least writing down these answers. Now, please remember, on an assessment, you need to be able to look and explain why it's a function or not a function.
Mr. Kennedy, did you just explain?
Because
why
because
the zero is not a function?
the 3 maps to multiple input.
Yeah,
output.
the 3 maps to -1 and to
Multiple
0.
output.
So that one input is mapping to 2 outputs. So if I ask you, hey, what's the output of 3? What would your response be?
We don't know.
We don't know, because there's 2 possible answers, so it's not a function.
So what's undefined?
That's not a thing here.
That's
The
not a
slope
function.
can be undefined.
Mr. Kennedy, I thought that's not a function. Oh, it's going to the same. It's,
Yeah, remember this one is mapping to -2, and this one is mapping to -2. So if I tell you the input's 1, can you tell me what the output is?
Yeah, -2.
Yes, so that's a function. So there's my functions and not a functions. Now, don't forget, are these relations still?
Yes.
Yes, every single one of them is a relation. There's inputs mapping to outputs, those are relations.
Help us.
Go for it, Benny.
On the last one, all of them -1, so that means it's not a function. They all have the same input, but different outputs.
Well, think about it this way. Does knowing the input's -1 tell you what the output is?
No, but having an input instantly tells you what the output is.
Here?
Not right there, but I'm saying, we dealing with.
If an input tells you the output, then yes, it's a function. But we don't have that here. Okay. Finishing up, right here. This map,
Attention to the pledge.
is this a function?
Yes.
Of the United States of America.
Yes.
And to the republic.
They all have one output.
One nation, under God, indivisible, with liberty and justice for all. you may be seated. Hey, Pat, don't forget our 4 pink troops every day. Promoting safety, achieving unity,
Okay.
proactively, and serving.
Really quickly, notice, knowing the input's -3, do you know the output?
Yes.
Do you know if the input's 5, do you know the output?
Yes.
Yes, and 7. A lot of students get wary and say, 7 has multiple inputs. That's not a problem. If knowing the input tells you the output, that means one input maps to one and only one output. Over here, what's the issue? What input maps to more than one output? -2. That -2 maps to more than one output, so it is not a function. Okay?
One of the video. Baller.
Right here, last 2 tables. Is this a function?
Yes.
Okay. This one?
No.
Don't we read the table from left to right?
Unless it's a horizontal. Alright, hey, last couple here. We need to recognize. Hey, guys, y'all all packed up, and we should have this notes down so we can refer to them later. Is this a function?
Yes.
Whole class packed up.
No, that's not a function at the bottom.
This one?
No.
Right, remember that vertical line tells us one input has 2 outputs. One input has,
3 outputs.
in this case, 3 outputs.
Not the function.
Bottom one has 1 output.
Bottom one is a function.
So, really quickly, I want to point this out.
Also, guys, tonight, they say you make sure you do whiteout. So that means.
Arithmetic sequence here, is that a function?
Yes.
Arithmetic sequence is a function. That one is the isolated points, the gap, that is a discrete function. So, no, a line through it makes it continuous. Is when it's isolated points, it's discrete. So whether it's a sequence or a continuous line, is that a function?
Yes. 100%.
100%.
What's the first word you use?
A sequence.
Sequence, if it's a discrete sequence or a continuous line, is it a function?
Yes.
Yes, one input is mapping to
1 output.
one and
Only
only one output. What about if it's a geometric sequence?
Exponential curve.
It is an exponential curve, but is that a function?
Yes.
How?
Yes.
It's discrete.
If it go down, hit the one
But
side.
look, how many outputs does this one input have?
Yellow.
Each input is mapping to one and
Output.
only one output, so is it a function?
Yes.
If I make it a continuous exponential curve or exponential function, is it a function?
Yes.
Yes. So we need to recognize that these sequences and these continuous versions, they're all functions. One input is mapping to one and
Only
only one output. Go back to that definition.
Oh, yeah.
That's all I got. If you want to pack up and get up to the door, you can do that.
Ben did that.
Oh my God, Nick.
Do I stop this?
Yes.
Yes, please stop it.